So this is number 2 on week 31 quiz, and it says if fx equals 2x minus 1, compute all values of x for which f(x) equals x. So if we input this into here, it's just going to become absolute value 2x minus 1 equals x. Because we're essentially just inputting this for x. And basically we can create a bunch of equations from this. So let's see if x is, if this whole thing is greater than 0, then we can write an equation. So we can just say that like 2 times 2x minus 1 minus 1 equals to x. And if this is not greater than 0, we can just have it be 1 minus 2 times 2x minus 1 equals x. So now from these two, we can create another equation because we have absolute values in it. And we could just say, if the 2x minus 1, if this is greater than 0, we have another two equations. So we first have 2 times 2x minus 1 equals x, and 1 minus 2 times 2x minus 1 equals x. And from here we can also make another 2 if the 2x minus 1 is less than 0. So it's just going to be 2 times 1 minus 2x minus 1 equals x, and 1 minus 2 times 1 minus 2x equals x. So we can erase these two, and now we just have to solve these equations. So first, for this one, we can just expand this term to be 4x minus 2, and combine these two to create 4x minus 3 equals x. Cancel out these three. We get minus 3x equals 3, so we get x equals 1. So now we can have one of this as our original answers. So another one is this one. So we can start by solving this. Expanding this, we get 4x minus 2. And we just get 1 minus 4x minus 2 is just 1 minus 4x plus 2, which becomes 4x plus 3 equals x. Wait, why is this freezing? Sorry, so it's just 1 minus 2 times 2x minus 1. And expanding this, we get 1 minus 4x minus 2. And this is just equal to 1 minus 4x plus 2. And that equals x. So combining these, we get 3 equals 5x. So our solution is 3 over 5. So on this equation, we can see that 1 minus 2x times 2 is just 2 minus 4x. And then combining these, we get 1 minus 4x equals 1. So combining these, we get 5x. And so we get 1 over 5. And finally, for this one, we have 2 times 1 minus 2x is just 2 minus 4x. And subtracting, we get 1 minus 2 plus 4x equals x. Cross out these. 1 minus 2 equals 3x. This is also minus 1. So we also get minus 1 equals minus 3x. So we get x equals 1 over 3. So we now have to check if each of these work. So if we plug it into our original function, which is just 2 times 2x minus 1, we just get, if we input 1, we just get 2 times 2 minus 1 equals 1. So to check this, we know that this simplifies to 1. So this just simplifies to 2, and we get the 2 minus 1 equals 1. So this is correct. Moving on to 3 over 5, we can see that it's just 2 times 2, 3 over 5 minus 1. And this simplifies to 1 over 5. So this is positive, so 2 times 1 over 5 minus 1 equals 3 over 5. So we can check if this works, and we get minus absolute value minus 3 over 5 equals 3 over 5. So this is true. So we know that this is true. So going to 1 over 5, we can see that 2 times 1 over 5 minus 1 equals 1 over 5. This will equal to 2 over 5, and this will equal to 3 over 5. So this will also equal to 6 over 5. And this will equal to 1 over 5. So we know that this also checks out. And finally, for 1 over 3, we can see that it's just 2x, 2 times 2x minus, not 2x, 2 times 1 over 3 minus 1 equals 1 over 3. So subtracting this, we get 2 over 3 minus 1, which is 1 over 3. And 1 over 3 times 2 is just 2 over 3. 2 over 3 minus 1 is just negative 1 over 3, but since the absolute value is just 1 over 3, so we know that this is correct. So our answers are just 1, 3 over 5, I think 1 over 3, sorry, not 1 over 3, 1 over 5, and 1 over 3. So these are our answers. So we also have question 5, and question 5 says, if x and y are non-zero real numbers such that x absolute value x plus y equals 3 and absolute value y plus x cubed equals 0, then what integer is closest to x minus y? So first we can see which ones are positive and which ones are not. So let's say x is positive. If x is positive, then that means that y would be negative, because this would be positive, this would be positive, and this has to be negative for this to be 0. But if that's negative, then that means that this has to be 3 more than y. So x equals y plus 3. But that's way too big, because y plus 3 times y plus x cubed equals 0. This cannot be true, because x equals y plus 3, and so x cubed would be way too big for the whole thing to equal to 0. So next we have to just assume that x is negative. So if x is negative, then we basically just have y is positive, because if y was negative, then this would be equal to a negative number, not 0. So now we just have to say see that x cubed, so we know that x y minus x cubed equals 0. Like, we're assuming that x cubed is a negative number here because we assume that x is a negative number. So now we know that y is x squared because x times y equals x cubed because x cubed is a negative number. So if y equals x squared, then we also know that y minus x equals 3 because from here we assume that x equals 0. X is less than 0, so this flips. Now you can substitute x squared for y, and we can see that x squared minus x equals 3. So now we can factor this and it becomes x minus 1 times x equals 3. So now we need to find two numbers that differ by 1 that multiply to 3. So we just like guess and check, and we can see that, for example, if x was 2, it would equal to 2, which is too small. If x was 3, it would equal to 6, which is too big. So if x was 2.5, it'd be 2.5 times 1.5, which is too small. And we know that this is equal to too big, because this is equal to 3.75. And we end up with 2.3 times 1.3, which is equal to 2.99, which is really, really close to 3. So we can just assume that x is 1.3, negative 1.3, because over here it says what is the integer closest. So we don't have to measure that accurately. So now that we know that x minus 3 is x equals minus 1.3, we can see that we also know that y equals x squared. So y equals negative 1.3 squared. So y equals 1.69. So using this, we can solve for x minus y, which is just 1.3 minus 1.3 minus 1.69. And we know that this is going to be equal to 2.99. Negative 2.99. So rounding this equals to negative 3. So the answer is negative 3.